Hey guys, hello everyone and welcome to the channel. Welcome to another part of Aptitude for CSIR NET series. In this video, we are going to talk about speed time graphs. Now, speed time related questions are asked many times in CSIR NET exam. Sometimes they are asked in the form of numericals. Sometimes they are asked in the form of graphs. Okay. So we'll discuss about numericals in some other video, but today we'll talk about graph related questions because this is something which does not require a lot of mathematics. It only requires that you understand the graph, you understand how speed and time and how they actually change and how the graph looks like, and based upon that you'll be able to answer questions from various in various CSIR NET exams, right? So that's what this video is going to be all about. Also, at the end of this video I will be giving you a homework question so that you can practice this concept and you can yourself test whether you have understood this concept or not. All right, so now without wasting any time, let's continue with our video. Okay, so to understand graph, the basic thing which you have to understand about any graph, okay, so if there are like generally these speed time graph are in two dimensions, so I'm just talking about 2D graph. In this there are two axes. Let's say this is the x axis and this is y axis. So what happens if y is constant? Okay, if y is constant, if y does not change, so if y is now y can be anything, it can be speed, it will be mentioned, it can be time, it can be distance, depending upon what exactly, or it can be acceleration, it can be anything. Okay, but if anything, any quantity which is expressed on the y axis, if that is constant, okay, or does not changes, okay, in that case that is going to be represented by a straight line which will be parallel to x axis. Okay, so this straight line is representing that y is constant, it is not changing. Similarly, if you get a graph where y is there and x is there again, and if y is continuously changing with x, okay, that means as the x is changing, y is also changing uniformly. Uniformly means with equal interval of x, equal interval of y is also changing. So uniform change in y is going to be represented by a straight line which is going to pass through the origin, and it generally makes an angle of 45 degrees. Okay, that's what this angle makes. Now this angle can be different, but what you have to look upon is that it should pass through the origin. Okay, a straight line passing through the origin, that is going to show you a uniform change in the y. Okay, now you can also have a graph which might look sometimes like this. That means y is here, x is here, and if it is going downside, that means now the y is decreasing with time. Now this one is also, both are uniform changes. Okay, this is also uniform change, this is also uniform change, but here y is increasing, okay, with x, means x, when the x is increasing, y is also increasing. But here what is happening, that y is decreasing with x. So when x is increasing, y is decreasing over here. So that's what you have to look upon. Now this is something about the basic of graphs, or the basic of x and y plots. Now I'm going to show you some standard graphs, and based upon that we'll do questions later, right? Alright, now there are some standard graphs which you should understand. There is a simple relationship between speed, distance and time. You know that speed is equals to distance upon time, and you should know that any graph in which on the y axis you have distance and on the x axis you have time, this graph is going to give you information about speed. Okay, so whatever information you get over here is about speed. Now over here if you look upon this, so this says that the so over here if you look upon this, the first graph, it says that the distance and time is there, and it is basically parallel to the time or parallel to the x axis. That says that the distance is not changing, distance is constant over here, right? That's what I can say, distance is constant. And if distance is constant, that means the body is not moving. right? There is no motion over here. So that's why it is mentioned that it is for stationary body. The body is not moving because distance is not changing. If their distance is not changing from any object, that means that object is at rest, right? Or it is at stationary, it's not moving. Then as I said, if you have distance and time graph, so that graph will give you information about speed. So this straight line is going to tell you about uniform as I said, given the graph passes through the origin, that is uniform, and it is uniform speed. It's going to give you uniform speed or uniform motion. That means equal changes of distance with equal change of y. Okay, as I have mentioned over here, that it is uniform change of y. Okay, with, and it is increasing with x. Now over here, if the graph goes not in the straight line but in the form of curve, then it is again non-uniform speed. And when the speed is increasing, that then the graph is going up in the up direction. Whereas if the graph is not a straight line but a curve, but the curve is going somewhere in the down direction or somewhere not if not going in the up direction, that's all is going to mention that the speed is decreasing and it's a non-uniform speed or non-uniform motion. Alright, so these are 4 standard curves which you have to understand. Again, there are some more graphs. As I told you that there is a relationship between distance and time. Similarly, there is a relationship between speed and time or velocity and time. Okay, so if you have a graph which is being plotted between speed or velocity, right, and time, so this graph is going to give you information about acceleration. Okay, so whatever information you get from here is about acceleration. So see the first graph, the velocity is that you have a straight line, that means the velocity is constant, velocity is not changing or the speed is not changing, so it is a constant speed. That's why the graph is parallel to the x-axis. Now over here, when the graph passes through origin and in a straight line, that shows uniform acceleration, right? If the graph is not straight line but a curve, so it's a non-uniform acceleration, increasing. And here the graph is going in the downward direction, that means it's a non-uniform first of all because it's not a straight line, and it's a retardation or also called a deceleration. Deceleration or retardation means the body is now slowing down or the speed is decreasing. Okay, that's what is retardation or deceleration. Alright, so these are some standard graphs which you need to know. Now once you have understood them, now let me just tell you the equation as well. The equation is that acceleration is equals to velocity upon time. Okay, this is the relation or this is the equation which is being followed over. Now let's look upon some questions from the previous year of CSIR NET exam and let's see how to solve them. Okay, so this is a question which was asked in CSIR it was asked in CSIR June 2021 exam, which held in the month of February 2022. So this was the question over there. It says that a girl is running at constant speed to catch a bus with us, which is stationary, right? But she reaches the bus and the bus leaves and moves with a constant acceleration. All right. Now it says which one of the following graph describes the situation correctly. Now understand what are the points given to you. Okay. So what about girl? So girl is running with constant speed. Okay. So girl is running with constant speed and its speed is not changing at all. What about bus? Bus was initially at rest, but then what happened to bus? That it started to move with constant acceleration. So then it moves with constant acceleration. Now if you just plot both the graphs separately, if I just talk about the girl, okay, just plot for the girl, and if I plot a speed versus time graph, so since it is moving with a constant speed, the graph should be like this. And I am making dotted line because for girl the dotted line is being used. Alright, so that's why it should be a straight line. Okay, so that shows a constant speed of girl. And what about the bus then? So for bus, it says that initially it is at rest, that means it is not moving, and then it is moving with constant acceleration. Now we have studied that anything if it undergoes a constant acceleration, it should have a, okay, so let me draw for the bus. So again we have speed and we have time. So anything if it goes at a constant acceleration or uniform acceleration, it should follow like this. But here is the case where initially it is at rest, okay. So that means sometime it will stay in rest, that means the speed will be 0. After some time it will move with a constant acceleration. So the graph should not start from the origin because it moves with constant acceleration, but initially it is at rest, right. We have to follow both the things. Initially it is at rest means the speed is not changing, speed is 0. So initially the speed is 0 for some time, and after that it moves with a constant acceleration. So considering both the things, both of them, if you merge them and if you see, the correct answer becomes option number 2. That's what is representing the situation for bus and for the girl both correctly, right. So this is going to be the correct answer for this question. All right, let's take another question now. So this question was asked in CSIR June 2017 exam. It says that the velocity time curve of the body is given in the diagram below. The diagram showing the acceleration of this body as the function of time. Now again, the graph is a velocity time graph and the options are acceleration time graph, okay. So we have to be very careful and we have to understand the things very carefully, okay. So just look upon this graph over here. This is a velocity time graph. From here we will take all the information and then we will slowly plot it in the form of acceleration time graph. So now if you look upon this, what we can do is we can mark as different points because there are 4 things happening over here. So from 0 to, let's call it as point A, then let's call this as point B, and let's call this as point C. So between 0 and point A, what is happening? Let me just plot it separately so that you can understand. So this is time, this is velocity, and what is happening here, that there is a straight line passing through origin. What do we call it? We call it uniform acceleration, right? Or it can also be called as constant acceleration, okay. As I said, the speed time graph or the velocity time graph gives you information about acceleration. So this is uniform or constant, fine. So this is constant acceleration. Then if I talk about point A to B, this is from 0 to A, okay, from 0 to A. If I talk between AB, what is happening? Between AB, I will see that the velocity and time is following a straight line, which is like this. So that means the speed is constant over here, okay? Speed is constant. And when the speed is constant, that means its speed is not changing. In that case, acceleration is 0. Why does it so? As I told you that acceleration is equals to delta of speed on delta of time. So if speed is not changing, acceleration will be 0, right? If delta of speed is 0, the speed is not changing means change of speed is 0, right? That means acceleration will itself become 0. So acceleration is 0 here, okay. Now when I talk about point B to C, if I talk about B, C, over here I will see that the velocity and time, if I see, so the graph is going downwards with a 45-degree angle, as I said. So this is what? This is uniform retardation. Retardation, as I said, is nothing but reverse of acceleration, means it is also called as uniform, like retardation can be called as negative acceleration. Now we have to plot these 3 scenarios in a single graph, in acceleration and time graph. So I am just going to plot it like this. I am just going to take it like this, okay. So we are plotting acceleration here, time here. So you will find out that initially the acceleration should be constant. Constant acceleration, anything constant needs to be like this. Then this is from point 0 to A. Then from point A to point B, okay. So here is your point A. Then here is your point B. So point A to B, the graph should be here. That means 0 acceleration, right? But you cannot leave this without connecting, right? You have to connect them. For connecting, you just make a line like this, all right. Now between point B to point C, okay, between point B to point C, it's a negative acceleration, and that too constant. Uniform means constant. constant negative means if this is acceleration, this upside is positive, downside will be negative, right? So it should show a negative acceleration. Again, you cannot leave the graph like this, you have to connect it. So this should be the correct answer, which is here in option number B. Alright, so this is how we have converted a velocity time graph into acceleration time graph with the knowledge of how velocity changes into acceleration. I hope you understood this. Alright, so now is the time for the homework question for this video. So the question over here says that a car initially at rest moves with a constant acceleration until it attains a constant velocity. Now it moves with a constant velocity for some time and then it applies brakes to undergo non-uniform retardation and comes to rest. Alright. Now which graph correctly depicts the situation? So all the things which are mentioned over here, you have to analyze it properly and then you have to see that which of these graph A, B, C, D are the correct representation of the given situation. I hope you will be able to answer it. It's very simple. Now is the time when we are going to look upon the solution of the homework question of the previous video. Alright, so in the previous video, I asked you guys regarding a question which says that a chord of length 5 cm subtends an angle of 60 degree at the center of the circle. The length in centimeter of the chord that subtends an angle of 120 degree at the center of the same circle is. So to answer this question, first of all, I have to make a circle. So let me make that. Once I am done with it, all I have to do is so to solve this question, I have taken a circle over here and as per the given condition, it is said that there is a chord of length 5 centimeter. So let me make a chord AB which is of length 5 centimeter, okay, 5 centimeter. Now it makes an angle of 60 degree at the center of the circle. So if this is O as the center of the circle, if I join these points, so this is going to tell you about the radius, right? This is radius, this is also radius, and radius are equal to each other. Of course, this angle is 60 degree, and you know that if two sides are equal, the angles should also be equal. Similar question we have done in the video itself. So that will make these angles also 60 because overall all the three angles of a triangle are like all the sum of the three angles of a triangle is 180 degrees. So if one is 60 and other two are equal, they also needs to be 60, then only overall 180 you will get. So that makes this triangle a equilateral triangle. So what did we got? We got that triangle OAB is equilateral triangle. Now if this is a equilateral triangle, that means all the sides are of same length. That means we got that the radius for this circle is of how much units? As the same as the chord. That means of 5 centimeters. Now if you understood about the radius, once you have got the radius, they are telling that for the same circle. That means I have to draw the circle of the same radius. Now once I have drawn circle of the same radius, it says that what is the length of the chord which subtends an angle of 120 degrees. So if this is the center and if this is the chord, now this chord is, let's say, PQ, it is making, let's say, angle of 120 degree. Okay, 120 degree. So now they are asking what is the length of this chord. Okay, and it is mentioned that if this radius is already known, right, these are the radius which is nothing but 5 centimeter. So for this I have given you a direct formula, formula to do that, right? So if a particular chord makes an angle theta at the center, in that case the length of the chord, okay, length of PQ is equals to 2r sine theta by 2. This formula I have given in the video itself. Same formula we are going to use. So this will be 2, r value is 5 centimeter and then sine theta is 120 degree. So it will be 120 by 2, that will make it 60. Sine 60 value you should know. So the value of sine 60 degree is root 3 by 2. So if you put that, so it is 2 into 5 into root 3 by 2. This 2 and this 2 is going to get cancelled out and your answer will be 5 root 3, which is option number B. So this was a simple question based upon this formula, and simply you would have done this question easily, right? Many of you have answered it correctly. I'm very happy with it. So that's it for this video, guys. Thank you so much for watching, and I will see you guys in the next one. If you guys want, you can follow us on different social media platforms. The link are there on the screen. So follow these links, or the link are also there in the description of this video. You can follow us on different social media platform, and I will see you guys in the next one. Till then, have a great day. Bye bye. Take care. Hey guys, so Unacademy has launched a Revise India series. It is a free video series for CSIR NET June 2023 exam. In this series, you will be able to attend free sessions by the India's top educators for CSIR NET. These sessions will be very helpful for your CSIR NET preparation and for your June 2023 exam. So all you have to do is follow the link given in the description of this video. You will come up to this particular page. There are various educators whose classes you will be able to see. All these classes are free of cost, so you can watch these classes. You will be able to see the classes of all the subjects over here. So depending upon which subject you belong to, you can choose a particular class, a particular educator, a particular topic, and watch that particular class.